Max Planck is one of the most important scientists most people have never truly met, even though his ideas quietly shaped the modern world. If Einstein changed how we think about space and time, Planck changed something even more basic: how we think about energy itself. He didn't set out to start a revolution. In fact, Planck was a careful, conservative thinker who trusted classical physics. But in trying to solve one stubborn problem, he opened the door to quantum theory, the strange set of rules that governs the smallest things in the universe. Planck was born in 1858 in Kiel, in what was then part of the German Confederation. He grew up in a highly educated family and showed talent in many areas, including music. He was an excellent pianist and seriously considered a career in music before choosing physics. That musical background mattered more than it might seem. Planck often spoke about harmony, structure, and elegance, values that shaped how he approached science. He wasn't chasing fame or controversy. He wanted the laws of nature to make sense, to fit together cleanly like a well-composed piece of music. As a student and young researcher, Planck focused on thermodynamics, the study of heat, energy, and how systems change over time. He was especially interested in the concept of entropy and the second law of thermodynamics, which describes how energy spreads out and why certain processes are irreversible. This was not flashy physics. It was foundational, rigorous work, the kind that builds the underlying structure of science. Planck built a reputation as a serious, disciplined thinker, and eventually became a professor in Berlin, one of the leading scientific centers in the world. Then came a problem that seemed simple but refused to yield: blackbody radiation. A blackbody is an idealized object that absorbs all radiation and emits energy based only on its temperature. Physicists could measure the spectrum of radiation coming from heated objects, but the existing theories couldn't explain the results. Classical physics predicted something absurd: that at high frequencies, a blackbody would emit infinite energy. This was known later as the ultraviolet catastrophe, and it wasn't just a small error, it was a sign that something fundamental was broken. Planck tried to solve this problem using the tools of classical physics, but nothing worked. Finally, in 1900, he took a step that he himself initially saw as a mathematical trick rather than a philosophical breakthrough. He proposed that energy is not emitted in a continuous flow, but in tiny discrete packets. He called these packets quanta. According to Planck, the energy of each quantum depended on the frequency of the radiation, connected by a new fundamental constant, now called Planck's constant. With this assumption, the blackbody problem suddenly made sense. The measurements fit. The infinite energy prediction disappeared. At first, Planck didn't fully embrace the radical meaning of what he had done. He was not the type to celebrate disruption. But his idea was revolutionary. It suggested that at the deepest level, nature might be granular rather than smooth. Energy, once assumed to be continuous, could come in indivisible steps. This was the seed of quantum physics. Soon, other scientists realized how powerful Planck's insight was. In 1905, Einstein used the idea of quanta to explain the photoelectric effect, proposing that light itself could behave as discrete particles, later called photons. What Planck had introduced as a solution to one radiation problem became a key that unlocked an entirely new way of thinking. Over the next decades, quantum theory grew into a full scientific revolution, reshaping physics, chemistry, and technology. Planck's role in this story is unique because he wasn't trying to overthrow classical physics. He was trying to rescue it. And yet, the truth he uncovered could not be contained within the old framework. That's one of the most human parts of Planck's story. Sometimes the biggest breakthroughs come from people who aren't chasing a revolution, but simply following the evidence wherever it leads. Planck's life was not defined only by science. He lived through an era of immense upheaval, including 2 world wars, and he experienced profound personal tragedy. He lost close family members, including children, under heartbreaking circumstances. Through it all, he continued working, leading scientific institutions, and supporting the continuation of research and education. His resilience gave his scientific legacy a deeper human dimension. He was a man devoted to reason and stability in a world that often offered neither. In 1918, Planck received the Nobel Prize in Physics for his discovery of energy quanta. By then, quantum theory had grown beyond his original equation into a global transformation of science. Yet Planck remained a figure of dignity and humility. He understood that science is built slowly, often painfully, through mistakes, debate, and persistence. He once noted that new scientific truths do not always triumph by convincing opponents, but often because a new generation grows up familiar with them. It's a quiet observation, but it captures the reality of how progress often works. Max Planck died in 1947, but his influence is everywhere. Planck's constant sits at the foundation of quantum mechanics, appearing in equations that describe atoms, electrons, lasers, semiconductors, and much of the technology we use every day. Without Planck's discovery, there is no modern electronics, no quantum physics, and no clear path to understanding the microscopic world. Planck's story is a reminder that reality is sometimes stranger than our most trusted theories, and that true discovery requires humility. He didn't chase shock value or fame. He chased clarity. And in doing so, he revealed that the universe, at its smallest scale, moves not in smooth flows, but in steps. In a sense, Planck didn't just solve a physics problem. He introduced a new language for nature, one quantum at a time. If you want more fun facts from science history, subscribe to this channel.